2017 linear motion question 1b is a baggage chute with two sections. PQ, it's the first section we're going to deal with. It's a quarter of a circle with radius r. It's smooth. We're asked to find the speed of the bag at Q in terms of r. QR is not smooth, it's rough, and mu is equal to mu. The bag comes to rest at r. Okay, so the speed between P and Q, we're going to need to use potential energy and kinetic energy formulas here. Potential energy is mgh, which in our case the h is r. So mgr is the potential energy at P. The kinetic energy, well, it's at rest, so 0. So this is at P. At Q, what's going on? At Q, the energy is kinetic energy, and my formula for kinetic energy is a half mv squared, and the potential energy at Q is 0. So the energy at P is equal to the energy at Q. Should enable me to get speed. So let's equate these two things. mgr is equal to a half mv squared. Cancel my m's. I'm going to get 2gr is equal to v squared. So my speed at Q is the square root of 2gr. Part 2, find d in terms of mu and r. Okay, well, we need to get acceleration here. We have the speed at Q. So the speed at Q is the square root of 2gr. The speed at r, it comes to rest. We have my distance, we're told it's d. So I can get a in terms of, or d in terms of, so I can get a here. Let's just call it a. So your equation you're going to use is v squared is equal to u squared plus 2as. So 0 is equal to 2gr, if we just square that straight away, plus twice my distance d by my acceleration a. So the 2's will cancel. And I'm left with gr is equal to minus dA. So acceleration in terms of d is equal to minus gr over d. Now we have mu involved in this question, so let's do a little diagram to see what's happening here. So we have our bag of mass m, mg going down, my reactionary force going up, I have my F, my friction force coming this way, and I have my acceleration and it's slowing down, so minus gr over d is a. So we can say definitely that r is equal to mg, F is equal to mu times r, so F is equal to mu mg. That's mu mg. Okay, so it's going in this direction, so we're starting by going in that direction, and we don't have a force, so the only force is the backwards force here, so it's going to be minus F, so minus mu mg is equal to ma, m times minus gr over d. So my m's and g's will cancel here, won't they? My m's and g's, so will my minus signs. So what am I going to be left with here? I'm going to be left with mu times d is equal to r. And we wanted d, didn't we, in terms of mu and r? Okay, so d is equal to r over mu. Part 3 in this question, the speed of the bag halfway along QR is 7 meters per second. So halfway along here, we have the speed. So the distance is going to be d over 2, half the d. So we can write S is equal to D over 2. The speed is 7. My initial speed was the speed of Q here. U, the square root of 2gr. I have my acceleration in terms of gr and d. So my acceleration is minus gr over d. So S, V, U, and A. So that will enable us to use V squared is equal to U squared plus 2AS. And you can see we have R's involved here, so we have to simplify down in terms of R. So 7 squared is equal to root 2gr to be squared. You could do this in one step. You could write 49 is equal to 2gr plus twice my acceleration of minus gr over d times my distance, which is d over 2. Now we can cancel our d's and we can cancel our 2's. So we're going to get 49 is equal to 2gr minus gr. Okay, 49 is equal to gr. This works out quite simply. So r is 49 over g. And there's a relationship between 49 and g. R is equal to 49 over 9.8, which is 5, isn't it? R is equal to 5 meters in this case.